Hi, this is Nathan Tintle. In this Learning Goal video, we are going to talk about how to complete multiple two-sided tests to obtain an interval of plausible values for an unknown parameter. We will use the cancer sniffing dog dataset to talk about this learning goal. Now, we saw that there was strong evidence that Maureen's long-run probability of choosing the correct bag was better than 20%. But how much better? Well, she got 91% correct. That's 30 out of 33, but we know that her long-run probability is not exactly 91%, right? I mean, if we let her keep going and choosing bags, she's probably going to do close to 91%, but how close is close? Can we say something better than we think it's close to 91%? Can we kind of give an interval of values where we think the parameter exists? Well, let's start with a specific value. How about 70%? Do we think that Maureen's long-run probability of choosing the correct bag could be 70%? In other words, is 70% a plausible or believable value for her long-run probability? Well, how would we answer that question? We know this already. We do a test, right? Our null hypothesis would say, well, Maureen's long-run probability is 70%. The alternative hypothesis is that Maureen's long-run probability is not 70%. We would conduct a simulation. You can see the results here on the screen. Do you often get 30 or larger if her true probability is 70%? No, you don't. The two-sided p-value is 0.0079. We have strong evidence that Maureen's long-run probability is not 70%. We can say 70% is too far from 91% to be plausible. This is not a plausible value for Maureen's long-run probability of choosing the correct bag based on the data that we observed. Well, if 70% is too far, how about 80%? How will we answer that question? Same approach we've used a couple times already. Null hypothesis, Maureen's long-run probability is 80%. Alternative, it's not 80%. Do the simulation. The two-sided p-value, 0.13. That's above a 0.05 significance level. We don't have strong evidence that Maureen's long-run probability is different from 80%. In other words, 80% is a plausible value for Maureen's long-run probability of choosing the correct bag. 80%, close enough to 91% to be plausible. Well, we can continue doing this process. We said 70% no, 80% yes. You can continue testing values and testing values and testing values. We're showing you a sample of some of the tests we did here in this table. We tested a null hypothesis of 75.9%, ruled it out, not plausible. 76%, ruled it out, not plausible. 76.1%, plausible. We then continued sort of on the other side, on values greater than 91%, finding that 97.3 and 97.4% were plausible, whereas by the time you got up to 97.5 or higher, those values were not plausible. This approach of testing many different values for the parameter yields us a range of plausible values for that parameter, allows us to zero in and say something stronger about the location of the parameter. In this case, we're quite sure that the true long-run probability that Maureen's going to pick the correct bag is between 76.1% and 97.4%. Couple of words of caution. When simulating, you're changing the null hypothesis probability, not the observed proportion of success. This is a mistake we see sometimes when students are using the applet. You are changing the null hypothesis probability. You're saying, what if the null hypothesis was this? What if the probability was this? The value you observe, 30 out of 33, that's not changing. And if this seems really tedious, test this value, test this value, test this value. Good news, shortcuts are available. We will discuss those in other Learning Goal videos.